Hello, everybody. So, made it to the last night of class. Uh, Always an exciting time. We do have a couple more of the major learning objectives to cover still. Usually, the last day of class is we've already covered everything, but this is the first time the Java class is running 8 weeks, and it is kind of a tight squeeze to get everything in there, didn't it? And all we did was introduce the contents. We didn't have time to get very in depth for anything in particular. Just introduce the concepts and then move on to the next one, do some homework on it. There was a lot of stuff shoved into 8 weeks. It's an active subject, so hopefully even after class you'll continue to write code and get some more practice with it, and the things will seem more applicable. It's easier to make sense of them when we're not in the question like we are for class, but we're drawing on the end here. Still have a couple more things to go over. Two more of those, and then I have a list of odds and ends. So I don't expect this to take very long. They're fairly straightforward. And again, one of them is going to be exactly like the homework. It is very, very similar to the homework. I thought it was close to the homework, and then on a Zoom call in office hours a few minutes ago, I looked back up what the assignment was and was like, oh yeah, I changed my in-class example last year, so it is almost exactly the homework for the 5th week in a row, I guess now. So multi-threading is one of the major course learning objectives, and streams, which will include parallel processing for large collections of data. So parallel process, multi-threading is where we split up our task, and computer still only does one thing at a time, but it jumped between them in an organized fashion quick enough that we would say it's doing all of it, several things simultaneously. But really, it's jumping back and forth between those things so that they all end at the same time. It ends up being faster. And parallel processing is when we make use of multiple CPU cores. So then we have multiple processors working on a problem, which speeds things up a lot. Then we have, it's like we're assigning multiple computers to the problem. And they don't even make single core CPUs anymore. I don't think they do. There might be a couple out there, but yeah, I'm pretty sure they don't make single core CPUs anymore. So we'll see about parallel processing. Then I have a list of odds and ends as time allows. But since we did make it all the way to the last one of class and still have a couple major learning objectives to cover, after we go through that, I'll probably ask you all's opinion on whether you would like to see some of the couple odds and ends to fill out time, or if you would rather have that time to work on final projects and homeworks and final exam, which is the other note I have in here. Remember, the final exam, it's like the midterm, so debugging assignment should go fairly quickly. Also remember, there is the new technology report. And Brandon Lobster has had me in the class before. Everybody's seen that before, right? And it doesn't have to be an essay. I was talking to somebody about this in office hours. There are other options, though, like podcast or a blog, but a podcast or a blog with a V as in video is acceptable on that. So if you wanted to, you could just start a screen capture recording and go look up new technology and talk about it as you see it. And that would come as a blog, right? If you did it purely in audio, that would come as a podcast. You'd be like, okay, I'm going to Google new technology summer 2023 and then talk about the results that pop up. And that would be acceptable. You don't have to write a formal essay on that. A lot of people seem to do that. But we can do better in 2023, right? If there's some information to share, we can do better than black letters on a white background in 2023. So a blog might make that really, really quick. Just start a screen capture and talk about the search results as you're seeing them yourself. That would be acceptable for the new technology. And probably really make it really, really quick to get that assignment up. Which is where 50 points, so don't get that. I think maybe 35 in this class. Some classes it's 35 and some of them it's 50. I think it was closer to 50 in this class. Exams on the calendar schedule, so get that knocked out first. Right, that one needs done by Saturday. A quick debugging assignment. Otherwise, everything, make sure you get everything to me by 11:59 p.m. on Sunday. I never accept late submissions beyond that date. That was the date. That was the final deadline for the class that was set years ago. So I never extend beyond that 11:59 p.m. on Sunday. First thing Monday morning, I'll wake up, finish any grading that still needs to be done. I'm usually done by 7:30, but I have an online SDEV 220 class this home, and I think some people are struggling with the Django for the final project, so I might have a whole lot of things submitted at the last minute that have to be graded, and a whole bunch of Django projects that have to be graded first thing in the morning. That'll take more than an hour. But I do wake up early and I will get the grading turned in and the grade submitted early Monday morning. So please make sure you get everything to me by then. It does not apply to anybody here. In the past, I've had people try to submit the GitHub URL and then turn in their homework afterwards, then upload the assignments later. If it hasn't been stated before, I don't look at the current version of the repository when I grade. I go to the history. I check the history. I look at what was going on in that. But over the years, a few people have tried to sneak that by. That is not for anybody in this class. That is for the recording when I post that up on YouTube. Because yeah, make sure that's on the recording somewhere. I don't look at the current version of the repository. I look at the history on the repository. I read everything you submit. So even if I'm completion grading an assignment, I read every line of code in there. And well, on the repository, I still check the entire history that would relate to that assignment. So yeah, make sure everything gets to me by 11:59 p.m. on Sunday evening. I guess our last two topics here to cover. We'll start with multi-threading. There's a little bit more to that. And as far as notes, I'm going to draw a picture. I'm just going to do some pictures here. So currently, that's not what's called currently. Currently, a flowchart for our software would look something like this. We have our start. I'm going to overly simplify it. So let's assume there's like branches and loops here and stuff. And it just comes straight down to the end. And maybe somewhere in here, like right about here, we call a method. I'll just call it M1. So we start doing some stuff, right? Maybe the initialization, then we call our first method. Computer goes and does that method, jumps back over here, picks up where it left off, and then maybe down here there's another method call, M2 and M3, and that's probably enough for the picture. And we have separate methods that we use to organize our code and stuff, but we're still basically running sequentially, right? We start here, we hit this line, method 1 runs in its entirety, then comes back over here, and then we progress on down to method 2, runs in its entirety, then we come back, and we're doing it all at once. So multi-threading, I'm going to abbreviate it here, multi-threading would be a little bit different in that we have our start point and we can actually separate these out. The reason I drew it with this squiggly line is they would be like separate program, almost like separate programs going through the CPU at the same time. So M1 might be something like this. Maybe M2 is a really, really long method. And M3, another short one, something like that. So maybe there's a situation where M2 does not depend on M1. They're completely independent of each other. It really wouldn't matter in our program if we called method 1 first or called method 2 first, because as long as both of them run, everything's fine. And we don't need anything from method 1 or method 2 to run. That's where multi-threading comes in usefully, because then we end up with things like this, where at the start of our program, we start running, and we can just call all 3 of those methods at the same time. Let the computer decide how to divvy up the work. It's still on just one single core, one of our CPUs cores. The computer decides how to divvy it up, and as long as they all get finished before we hit the end of the program, we'll bring them back together and then have the results of those to just throw out at the end. So basically, our criteria is the breaking points in our program, right? We take this one long string and then break it up in little pieces, move some of those pieces over independently. As long as they don't depend on each other, then we can set them up to run concurrently. Technically, it's not concurrently. One CPU core can still only do one thing at a time, but it jumps back and forth between them very, very rapidly. So for all intents and purposes, it seems like they're running at the same time. We also, I guess it also needs to be a situation where it doesn't matter what order they finish in. If the CPU looks at this and says, okay, there's the most work in method 2 here, so it does. I'm trying to color code it. So the blue comes over there. It's like, okay, the most work's here. So it splits it up and does a whole lot of that work. Then jumps over here. Does a little bit of method 3, then comes over, maybe runs all of method 1. Then back, does just a little bit of method 2, comes over here, finishes method 3, and then comes back and finishes method 2. That's just one situation. The next time we run our program, it might be entirely different. It might do all of method 3, then come back to half method 1, and then start jumping back and forth between method 2 and method 1. So it would run differently, but that's one possibility. As long as that's not going to mess anything up, right? As long as method 2 doesn't take in as a parameter the output of method 1, and we find that it doesn't matter which order we run them in, as long as they all run, as long as they all come back together before the end of the program. The 2 words, and it's the 2 words that always go poorly in lecture: synchronous and asynchronous. And I spelled that wrong. Synchronous. O-U-S. There we go. So those 2 words that if they're both showing up in the same sentence, we have to leave out articles, and right, a and the have to leave out the articles, and we end up with non-grammatically correct sentences, so that it's clear which one we're talking about. Synchronous means they'll run together. All of them need to finish at the same time, which is kind of what this picture is, right? It has them all coming back at the same. same time. But that doesn't have to be the case. Asynchronous means it doesn't matter. As long as it's finished before our software finishes running, that's fine. We'll go on and do other stuff. So for asynchronous, I guess the picture, I'll put it in green. Synchronous would be the blue one. And asynchronous, I'll draw an arrow in green. So when we get to the end, maybe method 1 finishes here, and method 2 over here somewhere, and then method 3 comes in right at the end of our program. They're spread out when they come back together. It doesn't matter. They could come back at the same time. That happens occasionally, but we are not going to wait for them at all. We let me add something else to that green arrow. So method 1 came back here, and then we just ignore it until we get down to the point we want it. So it doesn't matter where it comes back. We're not going to pay it any attention until we get to that spot later. Same thing, synchronous and asynchronous always, right? Either together or separately. Fancy words for that. 2 ways we can do it in Java. We decided I'd split it up, but basically our options will either be by task or by instruction. And in Java, we make a new option. So if there's a particular instruction or task we wanted to carry out, we split it up on each of those instructions that we wanted to carry out, each of those tasks, and then each one gets its own object, and it will either extend the thread class, so it's a child of thread class, or it will implement the runnable interface. So the obvious discrepancies there is, you all might remember back when we were talking about object-oriented, that we can only inherit from one parent. So if our object has another class that we need to inherit from, then the thread class is out of the picture because we already inherited something. We can't do multiple inheritance. And in that case, we'd have to use the runnable interface because we can implement lots of interfaces at once. Am I still on the board here? Yeah, so thread. We either extend thread. So extend class, or am I still on the board here? Yeah. A runnable, which is an interface, so we implement the interface. The advantage on runnable is we have multiple extensions. So we can have more than one interface. We can have the runnable interface and the serializable interface, so we can write it to a file, and the comparable interface, so we can have a greater than and less than option. Lots and lots of, we can do lots of interfaces. But as far as the parent-child relationship, we can only do one. The advantage here, which I'll do that as a big plus sign. So that's the big advantage on it. And the advantage on thread is we have interrupt and yield methods. I might have spelled yield wrong. Yes, I spelled it right. So interrupt means we can stop the CPU from doing something else. Like the mouse and the keyboard always have interrupt priority. And no matter what your computer's doing, you should be able to override whatever the computer's doing with the key press. So the key press can interrupt anything else on the CPU. It's like that, only obviously the keyboard and mouse could still interrupt our thread, but we can set it so that our thread has the authority to interrupt anything else the CPU is doing, except for listening for keyboard and mouse. We can't override the human priority, but as far as software goes, we can say, hey, we're more important and run our thread instead. That does require being a child class, and yield is the same thing. So that, if an interrupt might happen, we set up what to do if an interrupt is going to happen. Or think of it a level. We set a priority level. So we say, okay, if a level 3 interrupt comes in, we're not going to stop for it. We're more important than a level 3 interrupt, but if a level 5 interrupt comes in, that if some other software with like a priority level 5, once the interrupt, we'll stop for that one. And then we set up a few things like save some variables and maybe back stuff up to progress or something, right? If this thread is going through a database with 50 million entries, we don't want to start over if something interrupts us, right? Right. If we're 5 million records into our database, we don't want to start over in the case of an interrupt. So we have those with the class. Yeah, then we just fill in the run method in both of them. Create an instance of the object, instantiate an instance of the object we created, and call the start method. Which one is it? And in Runnable, we have to write the start method. In Thread, I think Thread we don't have to. Yeah, let's look at an example. Start up NetBeans or whatever IDE you're using. I haven't done any companies. I just use NetBeans because that is the official one for Java, because Oracle owns Java. Apache is a subsidiary of Oracle. So as far as the Oracle Corporation goes, this is the only IDE made by anybody in the Oracle Corporation. So it's the one listed as the official one, but obviously not the only IDE in existence. I'll create a new project. I'll do it with Ant. So we've been doing that. Maven will work the same. We don't need anything special. We don't have any external libraries or dependencies. These are built right into the core Java language. I call it thread and runnable. That was a good name for it. Oh yes, also tonight we haven't looked at Java 21 yet. I installed it on my MacBook this morning and tried to do stuff while I was in a meeting. So I was still trying to talk in the meeting and write Java code at the same time. And while trying to do two things at once, my like 3 or 4 attempts didn't work. So I was like, I'll have to do this later. And I didn't get a chance to go back to it. But I did install it on my Mac so that we can take a look at Java 21. Right, where this stuff becomes optional, because if we're not, well, at this point, it would be optional. Because we're not extending anything, and we're not implementing any interfaces. So the compiler could write that part because we have to match the name of the file anyway. The main method is overloaded, and the main method has to be public and static, so there's no point in a human typing that. So the main method is just void main string args, or we have some other parameters we can pass into the main method now. I installed it and gave it a try while I was doing something else, and my like 3 attempts of multitasking didn't get it to work. But we'll take a look at it. Otherwise, the changes are like we normally see with updates to the language, where they're high level changes and something that's been well established for 20 years. There's a really, really small number of people that are actually going to implement those high level changes, because they're such obscure things. But this Java did change the main method and basic syntax to make it easier for beginners, but obviously a core change like that is going to take a minute before all the bugs work out. So really, it'll probably be Java 22 before we want to start using that extensively, unless you just want to help them look for bugs. So threads and runnables. Let's do a thread first. So I'm going to go into the package and create a new Java class. And I'll call it my thread. Sounds like a good name for it. So thread, like the notes just put on the board, extends thread, which is, notice it's not asking me to import anything. So it's at the core language, like int and boolean and string. Multi-threading is one of those, just what they consider some of the most basic functionality in a programming language they made Java. Even scanners we have to input, right? We saw those on like day 1 or 2 and had to import them. So we haven't seen it much in the classroom, but multi-threading is something you want to do every time. You want to break it up. You want to break it up by instructions. You don't want the flowchart that just goes from the beginning to the end. There might be branches on selection structures and loops and things like that, but basically beginning to end with no variance. You want to split it up, because the CPU will decide how to run it then based off the local resources available, what else is running at that particular time, and there's a lot of optimizations built into it automatically. So what do we need for a thread? I'm just going to give it a name. Let's say private string, call it name. Insert a constructor, or you see all the stuff that we inherit. We'll come back to that. I'm just going to insert a constructor for the name so we can pass that in. And then, oh, I didn't write it on the board. It was on my notes. I was supposed to write it on the board. I hope I mentioned it. Then all we do is override the run method. So I'll insert, we look at our overrides. From thread, there's this method run. So we just want to override the run method, which you can see that's a pretty easy one to type, public void run. And we do not want the super one. So I'll take out that line of code that's there. And put our own code in there. Which this is just the syntax for the multi-threading. Right? When we did the payroll thing, we might want to, our run method might be calculate everybody's gross pay. And then our next thread, that would be a good example. Calculate everybody's gross pay, and then after all those threads are done, then we do another set of threads where we calculate everybody's tax rates or something. That really wouldn't be a very good situation for multi-threading, because those depend on each other. But if we had multiple tasks to do, we would basically create an object for each one of those tasks. each of the things that need done, and then what needs done goes into the run method. So for us, let's just maybe print out running plus this dot name. We're going to run like a dozen threads at once. So every time it'll say that we're running thread 1, running thread 9, running thread 7, running thread 12, and it's going to jump back and forth between and choose. Let's see. I'm going to put this in a try catch block. And what I'm getting ready to put here could probably be done without the try catch, but just for good form, you always want to put a try catch in your threads because we're breaking our program into pieces and splitting them up. So we might lose some guarantees in there somewhere. Handle the error, right? Textbooks and tutorials, they're restricted for time, and exceptions are really a very unique thing, unique to our particular software. They always have the terrible example of if it goes into the catch block, stop running and print out a message. But that's what happens if we don't handle the exception. So, for example, the assignment last week, where you would look for a file and split it up into two separate files or three separate ones, which I got a couple of emails pointing out that I said do the one that was written there without the GUI, and received several emails pointing out that the assignment, the number before it, I think if it was 711, then or 1711, 1710 was the exact same thing without a GUI. So I need to put that in the instructions. But in that case, if the file was split up doesn't exist, one good option, if you hit that exception, the file not found exception, would be to create a new file and split it. Maybe put the message in that new file that couldn't find the file, who couldn't find the existing file, so just made a new one. And then the program runs to completion no matter what. Hopefully that never happens. And that's actually more common. Textbooks and tutorials give terrible examples of it because it is more common in actual situations for the catch blocks to be longer than the code we actually want to run. Our actual code goes into try, and in order to fix any problems that might happen, the catch blocks will often be way, way longer, but hopefully they'll never run. So I'm going to put it in here just because we're breaking our program into pieces and running it, so we definitely want to worry about exceptions in this case. Lots of things could go wrong when we do that, more than if we just put all our code in the main method. So I'm going to just go through the loop. Start at 0, I is less than, I don't know, math.random. I believe we looked at the random class, right? Okay, I thought so. If we looked at this one, I would switch this to the random class. So the random class has all kinds of stuff. The math library has our basic probability, a number between 0 and 1 that we can just manipulate to get all our other random numbers. And then the random library takes that and does stuff with it. So this is a number between 0 and 1, so maybe we multiply it by 10, then wrap that in parentheses, and turn it into an integer. So we'll go like 10 times on each one, plus plus, and basically just print out another statement. I'll say, whoops, not close. This dot name, so whatever name we give this particular thread, which is going to be a number, when we get to the main method, it's going to be thread 1, thread 2, thread 3. This one has run plus I, and let me get zoom stuff out of the way. plus times. And we'll just keep track of how many times each one is run. Then I'm going to do thread dot split. And we need a number in here for how many, at least this many milliseconds. So instead of the normal sleep delay that's going to be exactly that many, the thread dot sleep is at least this many. Because if another thread's running, we don't want to interrupt it. So after 100, it's like wait at least this long and then decide when you want to go through the loop again. That makes sense? Any questions? Comments from the Zoom call? Like thumbs up or one of the emojis or something? Make sure that's all clear because this will be a very important thing. And yeah, this is pretty much our entire example over that class. Okay. Yeah. Want to make sure it's clear because it's not complicated. It's going to take practice, but this is pretty much all we'll see over in class. Because now we can go ask for that in our main method. So the thread class, all we have is our run method. Override the run method that we inherited from thread. And a constructor, which basically this one just has a name so we can see which one it is. And I don't think I did anything special when I was getting ready here. Took some time measurements, but we can add those in. I'll just do a loop here. So for int I is 0, I is less than, I don't know, let's do it 12 times. And increment was 12 threads seems like enough, but we'll see some differences. So each time we'll create a new myThread object. Let's call it T for thread. It's a new myThread. And we need a name. So let's call it thread underscore plus I. So thread 0, thread 1, thread 2. Since that's going into a human sentence, I'm going to do 1 to 12 instead of 0 to 11. It's easy to forget we can do that as programmers, right? It's like, all right, going through the standard for loop, start at 0, go to 11, that's 12 times. And then we print it out and then notice like, oh, wait, this is going to something a human is going to read. So we should probably go to 12. We should probably go 1 to 12 instead of 0 to 11. And then we just started. So now that we have one, we'll start that thread. So we override the run method and then we implement the start method. Run this. Is it running? Oh, there it goes. I am going to move the output up here. Bigger output, but we can see what happened. Right? So it started thread 1, but it didn't do anything. It just moved on to starting thread 2. And then it went ahead and ran thread 1 0 times. Oh, whoops. That's another one that should probably be 1 to 12 too, right? 1 to, yeah. It would make more sense if that one started at 1. So let me put 1 in there so it makes nice. There we go. Oh, this time it didn't even start with thread 1. It started with thread 2, then thread 3, then thread. So you can see the order breaks down on us. We can't rely on which one's going to happen first, which one's going to happen last. But what we can rely on is they are all going to happen. To the extent that what I was talking about a moment ago with the try catch blocks. We're not usually all the programs we've wrote so far run the same way every time, right? Every time we hit run, it does the exact same thing, the epitome of a machine. But now we can see it did something different than it did the first time. No changes in the code. If I hit run again, well, this time it started every thread before it actually started doing anything with them. It initialized every single one, and then it started doing stuff. So it's our program is no longer doing the same thing every single time. So that's why we want to handle some exception handling, which it just did that 3 times in a row. So I think the CPU figured out that it's optimized if it's optimal if it does starts all 12 of them and then does stuff and then starts calling the methods from them. Okay, then it splits it up again. But you can see something different happens every time we run it. Hopefully no surprises there. I guess I'll do the other one now real quick. There is one step more that we need in the runnable, so I'll make a new Java class. And I'll call this one my runnable. Get rid of these things, which I've deleted those every single thing we've done this semester. So I probably should have changed them in the template at the beginning of the semester. Then we'd have a better template. All of your IDEs should have that. You should be able to go in and customize your templates and generated code. And oftentimes it will usually be worth it. And when you're out there working, a lot of companies will have policies about what they want the template, what they want it to look like. So it's not a bad idea to go ahead and put that stuff in your template, and then you don't have to worry about it again. This time we want to implement, or our keyword is implements with our S, the runnable interface. And if I come over here, well, once again, you can see I don't have to import anything. That's not where the error is. It already found it. So this is threads and runnables are part of that very core, most basic level of the language, like integers or ints and booleans. Not even integer. Integer is the one with the capital I that has all the object properties, right? This is back at like int and double and boolean and just our most basic data types. This time is not abstract and does not override the run method. So threads have a default run, but we want to get rid of that. It doesn't really do anything. So the interface one does not have a default for that. So we need to click the little light bulb and implement abstract methods, which you can see is just that one we already knew about. I'll do the same thing. So let's give it a string called name. Insert a constructor where we can pass in that name. And then the same thing, I might as well just copy this. For example, I'm just going to copy the same task over. We don't want to overcomplicate our example. So to keep it clutter free, I'm going to use the exact same thing. We're saying which thread we're running, how many times it's run, and a brief pause between each run so it can jump, so that it doesn't run all the way to the end before, so that it splits up. Multi-threading is usually for big things, right? We got a database. If we need to look through 50,000 customer records to find a particular sale. Probably be more efficient if we could split it up into instead of our program starting at the beginning and going through all 50,000, we split it up into 5 separate threads that each go through 10,000 of them. And they do it at the same time. And then the odds of finding the record we're looking for there's a better chance of finding it sooner. There's still the chance it could be the last one we look for, but there's a better, if we have 5 things looking for it instead of just one, there's a better chance we'll find it earlier. That's the sort of big task or what we would want to split up. I believe it has been mentioned in this class before. Java is for really big things, right? Python works great for small things and big things that we don't worry about on time, like machine learning algorithms, where even if we were in our fastest language, even if we were doing it in C++ or Rust, we would still start the program and go get lunch and get back from lunch and it might still be running. So in that case, Python is just easier. We can go with the easier syntax because we're going to wait even in our fastest languages. So we might as well use the easy language. But usually Python is used on more small things, and Java is pretty consistently used for very large things, very big things. But big software means big money, and that's what we come to school for, right? Get good jobs, get some experience, practice and stuff. Lots of places we can get good practice and things, right? Go Global, I met with him yesterday. We probably going to start doing some stuff. I've already filled out a few times. I've had to bring in their credits for people, and they don't have much documentation. So I end up going through people's projects line by line and matching course objectives to say what credits they get. But they have a pretty good program. I mean, if you live basically in the region for some for Baby Tech, you're in the same region where the city of Louisville will pay for the Code Louisville program for you. And one thing I can definitely say about them is one thing they require of the students is they have to make about the nicest portfolios I've ever seen. So as I said, I've had to dig through the portfolios a couple times, but it is almost always some of the nicest portfolios I've ever seen. Just a thought to keep in mind. I got distracted. Oh yeah, now I want to do the same thing. Let's do that 12 times. So for I starts at 1 because we're going to an English sentence. I less than 12. We'll just increment I. No surprise there, and then could have copied and pasted that last one instead of my thread. We want to my runnable. I'll call it R. That's a new my runnable. And thread underscore plus I, whatever number we're up to. And then the start method. And this is where it's different. On the thread, it already had the start method. We didn't create that, but notice it doesn't know what the start method is. So this is the difference between them. We have to actually create the start method. Which is just a public void method. It doesn't send anything back because when we split our program up into all those different threads, sending something back would interrupt something else. So we want our run and our start to be voids. Oops. Called start, which obviously this one's not built in, so we could call it whatever we want, but we need a method to start it so the word start just makes sense, right? And in our case, I'll just say that we are starting plus whatever thread it is. And the reason we want to do this is we want to make sure if we're on the interface, we need some stuff from that object. Did y'all notice that? Whenever it showed up when I did the constructor, right? If I insert a constructor, we see we have the option with the fields we created. But if I come over here to my thread, the one from the class, and I hit Alt Insert and try to put in a constructor, notice that we have 2 panels full of things we can choose from. So we need some of that other stuff. The other stuff we need is all static, so we don't have to, or there is static and non-static stuff in there. We could use the static version. It makes more sense in my mind to just instantiate it. Because if it's static, we can still create an instance and use the instance to get to it. Wait, sorry, I jumped ahead in my example. We haven't made the thread. So all that stuff in the thread, we will need that. So if we come back up to the top, along with the name here, let's create a thread for it to run on. Call it thread. Sorry, I forgot I had to type that in there and started typing the next part of the code. And then an instantiation thing, which we haven't done much this class. So if that thread we just created, I'll put this dot thread. If that is null, this is something we haven't done much in our class examples, but as you move forward, especially into more professional settings, where it's not as highly organized as a classroom, and you might be doing arbitrary things at times, you quite often want to check if the thread is null or if this dot thread does not equal null. Whichever one makes more sense in your mind, but just check if it's empty before doing before instantiating it. Because you don't want to accidentally erase something. Does that make sense? If it was already instantiated and we said it's a new thread, then we erase whatever was there. So you want to protect against that, which is just thread is null or thread is not null, and then you do something in an if else block, whichever one makes more sense in your mind. So if it's null, we'll create a new one. Thread is going to be a new thread. And there's the constructor wants two objects. New thread. I was expecting the predictive text to pull that up, or at least have a link to the documentation. But I didn't see a link to the documentation. I saw several links that looked like they were going somewhere else. But our thread has two things. We need a task it's going to carry out, and a tag. It's overloaded. So the task we're going to carry out, I'm going to say this, because this is a runnable, right? So we pass in this runnable type of data, and then that's going to be the task we want to carry out. And again, it's overloaded. There's several other ones, and then we need a tag to refer to it to. So I'm just going to pass in this dot name as the tag, or they called it a name. That works out pretty good too. It's used like a tag, so a string and a key value pair, a way that the computer can refer to it. So when we call this start method, we'll say we're starting our thread. If the thread is currently null, we want to make sure and instantiate the thread we're working on. And then not this, thread.start. Then we'll go ahead and call that start method from the thread. That's why I like to keep the names the same. So you can see there's a couple extra lines, but not many. Basically, we just check to see if we have a thread yet or not. Make the start method, hopefully that makes sense. Our actual run method is exactly the same. We're multi-threading, so we still need a thread. Yep, looks like it's ready, so if I run it. You can see kind of the same thing. It started the first 4, then it ran a couple of them, then it started the next 4, ran 1, and started 4 more after that. But we have that same thing. It's we hit run again, it does it in a different order. In a different order. And it seems to want to start stuff every time. That one kind of went in a very sensible order until we got down there. But there is something different happening every time we run it, which can be incredibly productive thing to put in our software. We want the predictability, but sometimes all we need is the guarantee that it's all going to run. We don't care when it's going to run, just as long as it runs eventually. Any questions on that? Hopefully it's straightforward, makes sense. I'll wait a couple seconds to see if anything pops up in the chat in case there's questions or something. Okay, 6:55. So that 20 minutes to the time you normally take a break, and the next set of notes has 1, 2, 3, 4, 5 lines on it. Oh wait, and the last 2 refer to the syntax example. So I think we can get through this before the break time and before the normal break time, and then I will let you all decide whether we should take a break and come back and look at some other odds and ends, or if you would prefer to have that time to finish up homework projects. The new technology report is still due. But remember, it doesn't have to be an essay. There, just hit pull out your phone and hit the record button and talk about what you're doing while you look up new technology, and then you have a podcast. Right? That would be very, very quick. Way quicker than writing an essay. Just talk about it while you do the research. Or a screen capture, and then you have a vlog. Those are valid options for that. You don't have to write an essay. Also, I would prefer those. People keep writing essays. I would very much prefer podcasted blogs. Okay. Yeah, we'll, I guess, basically take a vote on that here in a few minutes. There's one last thing to talk about, and this one's like your homework assignment. This one's exactly like your homework assignment. For the 5th week in a row, the only difference between the syntax example we do here in a moment, or one of the things we see in the syntax example, I'll make sure it's the last thing we see in the syntax example, and your homework is the number of times you run through your loop. You'll just have a bigger loop in your homework. So streams. Excuse me, I'm sorry. So not the file strings, not the buffer strings, like the reason string shows up in the English language. This is strings is something in our code. It's method strings. Maybe I'll call it that. I'm going to put it in parentheses, method strings. So this is strings that are in our code. This stuff's kind of neat. We've seen some data structures and processing capabilities that are built into it. How we walk through a tree, how things are organized in a hash table, or the connections in a graph. Little things like that. And strings are processing abilities that are combined in one package and clean themselves up afterwards. That's kind of the definition of it. Processing abilities combined into a single package to clean themselves up afterwards. Or in normal English, it's a bunch of preset methods we can use and put lambda expressions in that will filter our data set. That's all it comes. There, yeah. Streams. I would say collection of methods to initialize, filter, process, and clean up a data set. Clean up storage. And instead of the word collection here, that all in red, and say maybe like a chain of methods. So it looks like some sort of initialize method. We have some new class, right? A new class, I'll call it X. A collection. X. Angle bracket there, you can make sense of the collection. Like a list or a set or a hash table. We have some sort of collection, and we call it dot initialize method. Then we have a dot filter method. Filter one method. Dot filter two method. And we'll apply a bunch of filters on that collection of data and one long chain of methods. Then dot, I don't know, I'll call it math method or processing method. And then a dot finish method. Something to finish up with, clean up afterwards. And it's a long chain of those methods, so it ends up in one line. And that's where the string comes from. It's instead of a bunch of lines, it's just one long line that we flow through in a certain order. And the textbook takes like 50 pages to talk about it. Okay, yes, I did see that in the chat room, but yeah, I try to watch that computer. I just don't always catch the computer, the other one. So yeah, let's go ahead and do an example. I'm making a new project. And yeah, I already said we'd be finished by 7:15, which we're coming on 10 minutes. This is going to be really, really quick. Hopefully you realize that I said so. I'll call this collection streams. That's a good name for it. And I'm just going to do everything in the main method to keep it simple because we don't need separate objects. It would be better to do it as separate objects, right? Java is object oriented. We should strive to only have one line in our main method and use that to get to our own objects. Because then if we want to switch it to, like, say, a web interface, then we just need that one line moved over to the web interface and get away from the main method as quickly as possible. But for this, I'm just going to do it all here. So what do we need? We need some numbers. Let's make a set of integers. My set, that sounds like a good name for it. I can't remember what we did last time. Did we do a tree set last time? Or did we do a hash set? Okay, let's do a tree set this time. It doesn't really matter. I just want to use something different than we did last time. So remember the difference between the tree set and the hash set is one of them's in a tree and the other one's in a hash table. So if the data set is huge and we have to go back, add a step to go back to the table between every single data point, then that's going to add up. In that case, a tree would be better because then we just, every data point points at the next one. But a hash table is quicker. So it has to get pretty big before those extra steps add up. But in our modern world, with our very, very large data sets, pretty big can happen really, really quick. So I chose that based on, I'm pretty sure we did the other one last time. So let's do this one. Let's swap it out. But that's one that you would want to put thought into. It's like which is better, a hash table or a tree? Do we go back and look up where the next one is, or do we just point at it? Do we just point at the next one? In our case, let's say for int I equals 0, I is less than, I don't know what's a good number to go through. 25? Sound good? That seems like a reasonable example. A reasonable number for our set, but it's the computer, so it's going to go through a lot more numbers than that quickly. Let's add. Well, we just did the math.random, so let's make a new random object. Let's use both of our randoms as a new random. Right, math.random has that basic one that we can manipulate. And in a lot of cases, especially if you're jumping back and forth between languages, the name built into the random object are going to be slightly different between the languages. And in a lot of cases, it would be easier just to go back to that basic one and manipulate it to what you need, or quicker to do that than it is to go look up the name. Like if you're doing a deck of cards thing and you can't remember how to do the 0 to 51 as integers, or 0 to 52 as integers, instead of going and looking up the name, it might be quicker just to take math.random times 52 plus 1 and then floor that number. Right? That's a very easy thing to code up, but all of our languages do have this as well. So whichever one you want. Let's add a rand dot next int, which I think if we put a number here, it's an upper bound. Oh, yes. Little word showed up, says bound. So next int with the upper bound there. But if we couldn't remember the name of it and predictive text wasn't showing us the right thing or something, as opposed to going to the docs or somewhere and looking that up, we could just take math.random times 100 and floor it, and then we have the integer 0 to 99. Same thing. So sometimes it's quicker just to go back and recalculate that, because that's all the random methods do. They start with the 0 to 1 random number and manipulate it. That'll give us 100 random numbers. Here's what we print them out. SO. So that way we can see what they are. And okay, sorry. No, I have numbers. That'll give us 25 numbers, and then so nothing too fancy there. I guess I could leave it there. Sorry, that was just, I like to have the output on the right. There's no real reason for dragging those around. I don't even have a good reason to say that, except that I like, if they're both full screen, I like the output on the right. Probably split it in half too. Where's that? Yeah, I prefer to look at it this way with the output on the right or the bottom. But I guess I don't particularly have any other good reason to do that. So now we need to throw our string in here. So we can do things with it. So let's say my set, and To initialize it, we start by saying we have a string. What's a good one? Let's take the first 8 values we find that are less than 60. So we need 8 numbers. Dot filter. And here's where we can our lambda in. So where I is less than 60. Right, we have numbers between 0 and 100. We just need 8 that are less than 60. Maybe this is some sort of MIDI program. We want to choose 8 random sounds to throw in there. That'd probably be a very bad idea, but we don't want to go past 60 because it's the bass side, so we want to stay to the left of middle C, which is MIDI 59. Something like that. Trying to justify it. I made up the numbers first and then came up with the reason for them. So we get that. And then we can say for each one of those. This is why our collections have for each. We used it earlier, but this is what the for each loops are actually for. For each one of those 8 things we find that fit that criteria, so I'll call it I again because that just makes sense in a for loop. We'll take each one of them and print them out. I do S out here. I don't think S out here will work. No, trying to do the shortcut won't work here. For each of them, I lambda system.out.print I and then a comma. Oops. I plus a comma and a space. So see how we're doing all of our processing at once. I close that stuff on the left so that it goes in there. And the stream, it just flows down on one line of the code like a stream. Well, choose, set a spot, make like a new collection, like a new array that only has 8 elements. So we have 8 spots to fill, and then we'll start filling it up as we find numbers that are less than 60. And in our case, we'll just print each one of them out and not really worry about the last comma or anything. So we found the first 8 numbers that are less than 60. Which looks like it was our first 8 numbers. That shouldn't always be the case, though. Why is that coming in order? Oh, wait. There's another difference between a tree set. We did a tree set, didn't we? We're gonna change that to a hash set real quick. You can keep yours as a tree set. Import that. Notice now we don't necessarily go in the same order. 1, 2, 3, 4, 5. This time it only gave us 5 things. I don't know why it stopped. It was supposed to give 8, wasn't it? 1, 2, 3, 4, 5, 6. This time it gave us 7 things. So I think there might have been some. So there was probably some duplicates when it generated it. Oh, I know what it is. Oh no, that wouldn't be it. I was about to say maybe we only have 2 numbers less than 60, but I see a couple things in the 20s there. So I might have made a typo. See if you can fix that. But notice the hash set does not go in order, but the tree set comes in order every time. So maybe I should do it with a hash set because otherwise we're doing those things in order. Then we'll need. I'm going to print a line break so we can tell what's what. I was going to put a label there, but Yeah, this time I'm gonna do it differently. This time, whoops, I'm gonna, notice the first time I put the system.out.print inside of the stream. Um, this time I'm gonna switch it up and um, I'll put the stream inside of the print line. Just to show we can go both ways. So my set, again, we're going to create a stream. Then let's filter it. Let's say I or lambda, so we want to filter where I is less than 10, 12, I is less than 12. And then reduce is the one, yeah, you can see it in the preview. Reduce to some sort of accumulator, so like a sum. Our reassignment operators, like times equals, minus equals, plus plus, minus minus, all of those, that's what would go in here. So let's do some. Start at 0, and then we want two things in our lambda. So A and B, and we need to put them in parentheses, lambda A plus B. That's how we do it. Everybody see that clearly? Everybody following along? I'm going to highlight that for a second. Remember a few minutes ago, I said for the 5th week in a row, that your homework assignment is basically in the next example. And I'll stop talking there about that. So we're going to sum together our first, however many things, these 4 things. Oh, no, please. We sum together, everything that's less than 12. I had to think about what I was doing there. So everything in our set that's less than 12, there's a 2, 7 is 9, plus 8 is 17. 12 is not less than 12, and everything else is bigger than 12. So we had a 2, a 7, and an 8 added together to give us that 17. Everybody see how that was working? A very, very useful thing. A lot of coders like it because it makes one line and a very efficient line. And notice there's 3 parts. Initialize, filter, then do stuff. Initialize, filter, and do stuff. And, okay, sorry, this went 3 minutes longer than I thought, and there's still one more I want to cover. Because earlier we talked about multi-processing. Sorry, we didn't talk about multi-processing. We talked about multi-threading. But we have multiple processors on our CPU, right? We want to take advantage of that. And to split up between the different CPUs, we put our objects into a collection, right? It could be a linked list of the my thread objects that we created in the first part of the lecture. It doesn't have to be just numbers, or it doesn't have to be the perfect record from our database. Those my thread objects we created at the beginning of the night are objects, so we could just have a linked list of my threads. And then we could, once we have that, we can put them in a stream. Let's see how many processes I have. I believe I have 2 running right now. So I'm going to call this runtime. Get runtime. Built into the language. You can see that pretty quickly. Let me print that, show you what that is. Runtime, get runtime. It says I'm on a Java language runtime. I'm running on the JVM. And I happen to have mine set up, so I should have 2 of the 4 cores dedicated to the JVM. So after get runtime, I can say available processors. Okay, spell it wrong. Dot available processor. So it's like a string. We have an initialization and then to do something. I should have two cores here on mine set up to work with because my Linux machine is doing something. No, my Linux machine is done doing something, so I have all the cores to work with. I didn't think it was going to be finished, but um, 4 cores back, so I can work on 4 cores, not just 2 CPU cores. So multi-threading stuff across multiple processors by just making our collection those threads that we made earlier, split up our task amongst the different processors. In this case, we're just going to let's split up these 25 integers across multiple processors. I'll do the same thing as the first one. So I'll do an output. Well, I'm sorry, the last one. Let's create a stream that we filter. Actually, I'm not even going to filter. I'm just going to go right to parallel. I spelled that wrong? Yes, I did. 1R, 2 L's, and then a third L. 1R, 3 L's. And then I'll do the same reduce. An accumulator, so let's start at 0. We need 2 values to pass into our lambda. So they have to go in parentheses. Multiple values into a lambda need to put in parentheses. And then we'll just do A plus B. Oh, the question popped up in the chat room. Sorry, I didn't see that. I guess on the last one where we reduced. Remember our sets were randomly generated. So like mine's still here, it probably says something different this time. Yeah, so this time I got a different number, Janet. So not that. Oh, because you have a better computer than I do. Sorry, I thought you meant the accumulator was giving you 8. But notice how the accumulator is different. We're randomly generating that. That's the number of CPU cores you have. And on the cheapest machine cheapest laptop they sell at Walmart. I always do that. Even my Mac, which was way, way, way more expensive than my Windows machine, is still the cheapest Mac they make because I teach at a community college, so I need to make sure that whatever we do in class can run on the cheapest machine available because that's all some students can afford, right? That also happens at big colleges too. But at a community college where the average student is a parent, right, married with the average number of kids in America, 3 kids, don't all have a lot of money to buy the fanciest new Alienware computer, right? With 24 cores or something to do homework. So I make it a point to always be using the cheapest computer available because if it runs on my computer, it should run on any computer that people have. And it is the cheapest Windows machine, the cheapest Mac, the cheapest Chromebook. Oh, okay. So yes, that's always nice. That happens every single time in this class. Somebody's like, "What? That's more cores than I thought I had on my computer." Did anybody end up with less cores than you thought? Like, did you think you had an 8-core computer and it's showing 4? The other 4 could be doing something right now. Because right, the machine does stuff even when you're not doing the things. So keep that in mind. But if you consistently end up with less, right, like you're in it today, restart your machine 3 or 4 times, run an update, and you're still seeing a smaller number than the cores that you thought you had, then you might want to look into why you're not accessing all your cores. Some of them might be clogged up, broke down, maybe do like at least a partial reset. The factory resets where you don't erase your files. It just kind of cleans up the non-page pools in RAM, or the buildup of human readable files, which are even larger on a Mac that just kind of. Oh yeah, the code was already typed. Any questions about that? Your machine's not going to lie to you, Jenna. So if it's saying you have 8 cores, it found 8 cores there to work with. Okay, she thought she didn't think she had 8 though. Oh, did you think you had 4?
I didn't exactly know what the answer.
Okay, so that's how you find it. If you need to check, runtime.getRuntime.available processors. Also, are you all running Windows 11? Then you probably have you have at least the virtual GPUs, which if there's no need for them right now, the Java virtual machine might ask if it can use those as CPUs. Like, hey, can I use those virtual machines for a split second? And if nothing else is using them, it might do that. Maybe that's why you're seeing more than you thought. Be something to look into, something to check on. Yeah, pay attention to those last 2 lines, and you'll see what the homework assignment is soon. Okay, that took a little bit longer than I thought it was going to. So, what do y'all think? Would you all rather have the rest of our time this evening to work on homework, technology report? Grace is shaking her head very, very, very largely before I even finish the sentence. To get finished up on stuff. Or should we take a break and then cover other stuff? I see homework, so that's 2 votes for homework. Okay, it looks like y'all are more interested in catching up with all the work at the end of the semester. If you have questions, let me know. I'm always happy to help. It's the last weekend of the semester. Y'all have all had me in class before. So you've heard me say it before. The last weekend of the semester, I keep my schedule open. I have a meeting tomorrow at 8 a.m., which is probably earlier than you all wake up. And then I have one afternoon meeting tomorrow. Then I have one afternoon meeting from 2 to 3 tomorrow, I think. Is there another call about the internship, Jenna? Because last week I did not find out about that call. Oh, okay. She wakes up early. Last week I did not find out about that call until 3 minutes before, when I made a comment as our previous meeting wrapped up, that I had been on Zoom calls for 7.5 hours straight at that point. And then it was like, oh, finally away after 7.5 hours straight of Zoom call meetings. And was told, oh, wait, there's another one in 5 minutes that you should probably attend. I was like, yay. Okay, so I have one meeting at 8 a.m., one meeting at 2. Other than that, my entire schedule is intentionally kept open so that if you have questions, I can jump on a Zoom call and put that. Just let me know. As always, text messages and IVR messages are the 2 things that make noise on my phone. Any way you have to contact me is a valid way to contact me. So I have my schedule is open in case you need help. Let me know. Otherwise, you're all great one, and I will see you. Oh, I'll see. I hope to see you around soon. Everybody have a great fall break. That's right. That is our class. You'll have a wonderful fall break. It should be some nice weather, is what I heard. Try to relax a little, and I'll see you. Thank you for making it such a great course.